Xuan. I'm currently assistant professor at Department of Industrial and System Engineering, and also an affiliate member of ITI. And I direct the Additive Manufacturing Research Lab at ITI. Yeah, so my research interest is focusing development for next generation additive manufacturing, also known as 3D printing technology, and also interested in novel applications of those technologies in material discovery. And I have a background in mechanical engineering, industrial engineering, and computer science. And by combining those expertise, we invent and develop those hardware platform and their novel applications. So the focus area is development of next generation additive manufacturing processes. And currently we are mainly interested in ceramic and composite printing. One of our projects is using a novel additive manufacturing process to fabricate a new material called bicontinuous ceramic composites. And that material can convert mechanical stimuli into electrical signal, or conversely convert the electrical signal into mechanical vibration. So that can be used as actuator or sensors in extreme conditions.
I'm Levi Kirby. This is my third year in industrial and systems engineering as a PhD student, and I work in Dr. Xuan lab where we focus on additive manufacturing. In the lab, we mostly focus on additive manufacturing as mentioned, but highly dense ceramics has been one of the focuses. Right now I'm working on energetic material, where we're working on making explosives and propellants. Both of those are binder jetting technique, where you spread a layer of powder and you deposit a binder into that powder, and you do that layer by layer, eventually forming a solid part. In those two fields, there's not a whole lot of research at all in 3D printing. So right now we're just working mostly on proof of concept, but also just exploring what kind of capabilities we do have with 3D printing in those areas. With my research, a few things that I've taken away, really get to experience independence. You're given a project, but it's up to you to come up with a solution for that project, and that's something that I love. That's something that you don't really get until you get older, in most fields. But when you're in the research that I'm doing, again, I get to explore in any way that I think might help us out.
My name is Bentley. It's my 5th year as a PhD student. I come from Additive Manufacturing Production Integrated Realization Lab in ITI at the University of Iowa. Our lab is focusing on developing new generation 3D printing methods. As a PhD student in the lab, most of the time we are trying to figuring out new methods aiming at printing for some high-performance ceramic structures or involving some revolutionary new material structure that can beneficial the 3D printing community or even the whole industry. Right now, my research is focusing on a binder-free additive manufacturing or 3D printing method called hydrothermal assisted jet fusion process. This process is quite inspired by the liquefaction process in the nature, which is just like how you see those normal things like rocks or flows are formed in the nature, where dissolution and precipitation process are involved.